Good morning to you all. So, I am Salman Baris. Today, we are going to see the project on ABC call volume 10 analysis. So, that was given by Trinity. So, this is a part of internship that I have doing. So, ABC call volume 10 analysis is nothing but there is a company called ABC. So, they are call service center. So, company is based on call service center. So, many customers are try to call them, so they customers have some doubts, have some uses. So the company working employees, they will assist the customers. So and they give the answers through the call. So we directly go into the project. So the project description is, so project is about analyzing the patterns in various agents name and ID, the queue time, the time of the call, the duration of the call, and call status. So the goal is to attract, engage, and delight customers, turning them into the loyal advocates for the business. So we have to find a pattern. So we want to do some analysis. So how, the minimum agent record in the shift 9 to 10, 10 to 11. So for one day, so how many agents are required? So we are going to we did some calculations on average duration. So and many calculations, many analysis we have done. So we go into the project. So approach, so what approach have done is, so data understanding. So we are doing this project. It is based on CX analytics, so customer experience analytics. So we did some data understanding, researched on CX analytics and important features. So we have did some data pre-processing and data analysis. So data analysis mostly we have did some pivot tables and do some calculations, and also we have created visualizations. So finally, the conclusion and presentation. So explains the business driven, type driven, and data driven metrics created in the previous steps. So tech stack. So what are the tech stacks that I am used is, that is, I'm using only MS Excel 2016 for this project. So it is so I love MS Excel very much. So I used this for data analysis. It is a good tool for data analysis. Um, Before our project, they have given me the assumptions. So that's the assumptions is, an agent works for 6 days a week. On average, each agent takes 4 unplanned leaves per month. An agent's total working hours are 9 hours. So out of which 1.5 hours are spent on lunch and snacks in the office. So on average, an agent spends 60% of their total actual working hours on calls with customers and users. So these are the assumptions that they have give to us. So the first analysis is average of call duration. So 1 minute. So I will show my Excel file. So this is the Excel file that they have given to me. So you can see that agent name, agent ID, customer, queue time, date and time. So this is time bucket. So in this data set, the time bucket is the important variable. So with the help of time bucket, we are doing the many analysis. So we will see that later. So you can see that wrapped ringing IVR call status. So this is also the important thing. So you can see that there is 3 unique values in the call status. So that is answered, abandoned, and transferred. So answered means if the customer dialed the phone to employee, so representative. So the representative answered the call. So if the representative didn't answer the call, then it comes under the abandoned. So there are many null values. You can see that. So here it's a null value. Here it is a null value. So 1 minute we will filter the null values and see what exactly they are. So you can see that. So the when the null value is present in the agent name, also the null value is also present in the agent ID. You can see that wherever the null value is present in the agent name, also there presents the agent ID, because so agent ID is allocated for the agent name. If agent name is contains null value, then agent ID also contains null value. So you can see that. So and duration is 0 0. So duration, the communication between agent and customer is 0 seconds. So you can see that call seconds is also 0. So all the null values have duration of 0 seconds, 0 hours, 0 minutes, 0 seconds, and all the status for the null values present in the data set is abundant, 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 abundant. So we can, so by seeing observing this data, we can conclude that, so the customers, or customers dialing to the agent, so customers dialing the phone call to the agent, but after that they abandon the call, so we don't know the reason. So uh, so this is, we can conclude like this. So then the first task that allocated to us, time duration analysis. So we can take each unique time bucket, so 9 to 10, 10 to 11. So you can see that this is a time buckets. So time buckets is nothing but it's interval 9 to 10 a.m., 10 to 11 a.m. So and it's all keeps going like this, and then finally we can see that, so it's into 21 p.m. It's nothing but 99 9 p.m. So for each bucket, so we have see that average call duration is 199, for 9 to 10 199. So for 10 to 11 203, for 11 to 12 it's a 199. So this is the average call duration seconds. So so we have find out the duration, so average call duration. And also, so we have did some line chart, so you can see that this is a line chart. So we have taken a line chart, so this is also present. So what the findings we have done that, so in the morning 10 a.m. to 11 a.m. and evening 20 p.m. to 21 p.m. So we can see the high call duration and low call duration in the afternoon. So you can see that in the morning and the evening, so we have a high call duration. So the interaction between the customer and the agent is high in the morning and the evening, but in the afternoon it goes slightly low. So we can see this in the graph. So for afternoon, you can see that the call duration is 199, 193, 192. So this is in the afternoon. After the when the afternoon completes and the evening goes, it goes like 198, 1 200, 202, 203. So after that, so second analysis is call volume analysis. So call volume analysis. So in this call volume analysis, so we have taken the total calls in the each bucket. So in 9 to 10, the total calls obtained is 9,588. So in time in the time bucket of 10 to 11, we have obtained the total calls of 13,330. So and also we have find a percentage. So you can see that in the time bucket of 11 to 12, so we have obtained a more calls, so that is 14,626, which contributes to the percentage of 12.4 percentage. So you can see that. So and the minimum calls we have obtained in the night time, so you can see that it contributes nearly 4.67 percentage. So what we have done is we have did the visualization. So this is nothing but a visualization. This is nothing but a combo chart. It is a well-known and popular chart in visualization. So what I inference that what we have observed, that is the total call distribution is slightly skewed. You can see that it is slightly skewed on the right side. So most values are present in the left, higher most maximum values are present in the left side. So on the in the right side, minimum values are present, so not minimum values. So in the right side, you can see that the values are slightly decreasing. So total calls distribution is rightly skewed. At 9 a.m. to 12 a.m., we can see the increase in total calls. At 9 a.m. to 11 a.m., we can see that the calls, total calls is increasing. Whereas at 12 a.m. to 21 p.m., so at 12 a.m. to 21 p.m., we can see the decrease in the total calls. So you can see that there is a slanting line, that slanting lower line. So this is that. So this is the observation that we are concluded. So third analysis is a manpower planning. So manpower planning is nothing but, so we have to like so we have to obtain the man so labor, so agent, how many agents needed for each time bucket. So you can understand per day. So we are going to observe unless how many agents are required for each bucket per day. So you can see that we are used formulas. So first one is total available hours. So total available hours. So we previously we have did we have concluded that some assumptions like, so 1 minute I will show that presentation. So this is the assumptions. The agents work for 6 days a week. So 6 days a week means for month the 6 days a week, and average each agent takes 4 unplanned leaves per month. So these all are the observations assumptions that the company have given to us. So actually, so total available hours from the data given is 7.5. So call handling hours. Among 7.5 hours, the call handling hours is the only 60% is total occupation time, and so 4.5 hours contains 16,200 seconds. So total calls present is 1,70,988. So this is the average seconds that we taken from the task one. So these values are copied pasted into this area. So call handled, so call handled is nothing but, so um B18. So this divided by this. So this is a total seconds in a day. So this is a total seconds available in a day, and this is a average call duration for 1 day. It is denoted in seconds. Like, so this divided by this, we got this. So the call handle. So call handle is nothing but call handling seconds by average duration of the call. So total calls to be total calls. So we have total calls we have obtained from there. So 9,588 for this is for 1 month, but we have taken in the total calls we have taken total calls divided by 20, so per day. So total calls per day. So you can see that total calls per day. So this is also the total calls handled, so per day. So on top of that, so total calls to be answered, the formula is total calls to be answered is the total calls into decide rate. Decide answer rate. So we want to, so there is nearly in the data set we have 30% of abundant rate. So abundant rate is nothing but, so you can see that abundant. So out of 1 lakh data, so we can 34,000 values or contains abundant rate. So among 1 lakh 30,000 means there is a 30% of data. So 30% of the data contains abundant rate. So we need to reduce that abundant rate to 10%. So 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 we have to reduce 100% to 90%. So only, so we are taking, you can see that we are taking 90%. So total cost per day is 417. The total cost to be answered is 375. So 90% of 417 is 375. So we have calculator for each time package. So then we used the formula. So we divided it. So minimum agents required. The formula is total cost to be answered divided by calls handled per agent. So this is the formula. So we have obtained here. So you can see that E2 divided by C2. So this is the E2 total cost to be answered, and C2. So call handles per day. So and after that, so this is minimum agents required per day for 90%. So 90% success rate, answered rate. So and also we have created some beautiful visualization. So it's nothing but a line chart. We are already seen before in the task point. So you can see that. So 5786. So this is the minimum agents required per day of 90% success rate. So so you can see that. So we can observe that. So in the late nights, 1 minute. So we can see that the time packet, the manpower planning. So the time packet which have more calls and average duration leads to the more agents and voices. So see guys, so if the total calls is high and the average duration of is high in the time packet, then the agents required is also high. So you can see that uh, in 11 to 12, so the time bucket of 11 to 12, the time interval between 11 to 12, we need 8 agents. So why compared to all that, compared to all the buckets, so 11 to 12 bucket is the agents required for time bucket for 11 to 12 is high. It is 8. So it is high because we can see that. So it is average call duration. So it is at 1 minute. So it is high that, so because you can see that, so total calls for 11 to 12 it is high. So you can see that, so total calls in the 11 to 12 is 12.44 percentage, and it nearly contributes to 14,000. And also the duration is, so you can see that 11 to 12 duration is 199. So if the duration, call duration and total calls is high, then the minimum and the agents required is also high. So and also if the total calls and average call duration is low, the agents required is also low. So for totally, so for day shift for 9 a.m. to 9 p.m., so we need 63 agents. So you can see that, so 9 a.m. to 9 p.m. So totally, so we need a 63 agents to handle the all the calls that arrive in the ABC call ABC company. So this is a manpower planning that we have done. So you can see that this is the table that we already before seen in the Excel. So these are the formulas that we handle, that we are used to calculate the minimum agents. So next is night shift manpower planning. So you go into the Excel file and see the task code. The task code is nothing but the night shift manpower planning. So we did the calculations same as the task 3. So it is same as the task 3. So where they have given that, so call for every 30 calls, so for every 100 calls in a day receives for every 30. So 1 minute, I will show that. So we need, so every 100 calls, so 30 percentage calls arrive in a night. So right, so if there is a 1 lakh calls are arrive in a day shift, so that if the 100 calls arrive in a day, then 30 calls arrive in a night. So you can understand that. So if 100 calls arrive in the daytime, then the 30 calls arrive in the night. So 30% of the calls arrive in the night time, so night shift. So we can see that, so call distribution 3 3 3 3 and percentage. So we have did some percentage and the average seconds. So we have taken 198. So we don't we infer the average seconds from this data. You can see that. So this data. So we have find the total average. So that is 198. And so we have obtained, we have put average call seconds for each buckets. So calls handled, so calls handle this. So you can see that this is total calls handled, so 30 percentage of the data. So you can see that uh, the 100 percentage of total calls is 11,788. So 30 percentage of the total calls is 35,396.4. So we have calls handled. The formula is calls handling seconds by average duration of the call, average duration of the call. So total calls to be answered is, so this is the same formula that we have seen before in the task 3. So total cost to be answered. So we have we need to, so we taken a 0.9. So because we need to find a success rate, 90% success rate. Uh, in here also, so in night shift also, there are 30% abundant rate. We have to decrease the 30% abundant rate to 10% abundant rate. And the minimum agent required per day for night shift is, you can see that. So finally we have 10 minimum agents required per day. So and also we have created a beautiful shot. This is also line chart. So you can see that 2 2 2 2 1 1 1 1 1. So I will go into the presentation. So this is we can observe, this is a chart. So we can observe that late night, in the late night we need two agents. So late night is 9 p.m. to 12 a.m. Actually 1 a.m. So it is a late night. Midnight 1 a.m. to 4 a.m. Midnight we need a one agent. In the real early morning, so we need a three agents. So for night shift, totally we need a 23 agents. For night shift, we need a 23 agents. For day shift, we need a 63 agents per day. Uh, so totally in a day, so you need a 100 agents, nearly 100 agents. So 89, 90 agents. So this is the calculation. So we seen in the Excel file. So we directly copy pasted this. So and this is the formula that we used to find the minimum agents required per day. So that's all we have done. So what are the results that we have done? So toward the project, so I have gained a valuable insights into impact of an analyst in the customer service department. It is evident that the company strives to ensure the maximum customer satisfaction through effective customer handling strategies. So this project has provided me with a valuable knowledge and insights into the dynamics of customer service and the role of an analyst in optimizing the customer satisfaction. So and finally, so I have the given the workbook link. So if you click the link, so it is directly redirects into my Excel file where I have so this Excel file, you can see that it directly redirects into this Excel file. So where I have did some calculations. So you can verify that. So that's all. So that's all. Thank you. So if you have any questions, any issues, so please try to contact me on the mail salmanbarisxp@gmail.com. So that's all. Thank you guys.